When Energy Changes by Adrian Schuer, a nonfiction text with the essential question, what is energy and how can it change? Presented in 5 chapters. Let's begin. Chapter 1, Energy Basics. You know you use energy, but do you know what it really is? In science, energy is the ability to do work. Energy creates change in objects by applying force. Force is a push or pull. Forces put objects in motion. Riding a bicycle uses energy. That means it is work. Energy is all around you and comes in many different forms. Light, sound, heat, motion, and electricity are all forms of energy. Did you know that energy transforms or changes from one type into another? Where does energy come from? The sun is Earth's biggest source of energy. Energy from the sun is called solar energy. Sunlight is solar energy that lights and heats the Earth. Plants change solar energy into chemical energy. Animals and people eat the plants. The plant's stored energy is passed to them. Oil and other fossil fuels are the remains of plants and animals that lived millions of years ago. They have been transformed into chemical energy. Where does energy go? Scientific laws govern what energy can do. One is the law of conservation of energy. This law states that energy cannot be created nor destroyed, but it can change from one type into another. A car's engine transforms chemical energy from fossil fuels into mechanical energy to spin the wheels. Energy takes many forms. Not all of the fuel's energy goes to move the car. A lot of energy changes to heat. That is why car engines sometimes overheat. Solar, chemical, and mechanical energy are just a few of the types of energy all around us. Chapter 2, Changing Energy from the Sun to Make Cars Go. There's one car race that's like no other. Solar cars run on the sun. They use solar cells to change sunlight into fuel. In 2014, solar cars raced from Austin, Texas to Minneapolis, Minnesota. Despite the long distance, they used only the sun for fuel. This is a picture of one of the solar cars in a race. Making energy change. Solar cars look odd compared to other cars. Most are flat and covered in solar cells. The solar cells generate an electric current which fuels the car's motor. The motor powers the wheels that move the car. Solar cells make electricity whenever they are in the sun. When the motor is not in use, the electric current charges the car's batteries. There it is stored as chemical energy. The good and bad of solar energy. Solar-powered cars do not pollute the air. They have an endless supply of solar energy. Gasoline is made from oil, which has a limited supply. Solar energy has some problems, though. On sunny days, solar cells work great, but when it is cloudy or nighttime, there is no solar power. The amount of energy from sunlight is highest in the middle of the day. The sun's rays are weaker during the winter. Solar cars can use battery power, but without sunlight, the batteries run out of electricity. Scientists continue to search for better ways to store and use solar energy. These solar panels are collecting sunlight. The energy will be changed to electricity to use in homes and businesses. Chapter 3, Light Up the World. Who turned on the lights? The scientist Michael Faraday experimented with electricity. He discovered that magnetic fields affect how electric current flows in copper wire. A magnetic field is the area around a magnet in which the magnet's pushing or pulling force can be felt. This picture shows Michael Faraday, 1791 to 1867, doing one of his experiments with magnetism and electricity. Faraday built the first machine to generate electricity. His designs formed the basis for modern power plants. Some power plants use the energy of moving water and turbines to generate or make electricity. A turbine is a machine with large blades, like the blades of a fan. The blades turn as water moves over them. This generates electric current. The electric current then flows through wires, which form a circuit. When the current reaches your home, you can control it. Turning a switch on completes the circuit. The current flows. Turning a switch off breaks the circuit. A turbine powered by water generates electric current. Electric current flows from the battery through a circuit, When the bar is raised, the circuit is broken and the light goes off. Turning up the heat. Traditional or incandescent light bulbs have a thin wire called a filament. It is the filament that shines. Electric current becomes tightly packed as it pushes through the wire. This produces so much heat it glows. As the wire becomes hotter, it turns white. The white hot wire makes the light bulb bright. Flowing electric current produces heat. Heat causes the light bulb's filament to glow white hot. Turning down the heat. Light bulbs use heat to make light. It takes a lot of electrical energy to make heat. Yet the purpose of light bulbs is to produce light. The energy spent making heat is wasted. Fluorescent light bulbs make light differently. A fluorescent light bulb is filled with gases. An electric current causes these gases to send out UV, ultraviolet light. That UV light hits powders on the inside of the glass tube. Those powders then give off white light. Fluorescent light bulbs use less energy than those with filaments. They give off less heat. A light bulb with a filament can get very hot. A fluorescent bulb stays much cooler. Chapter 4. Energy you can carry. You probably use batteries every day. They are in cell phones, music players, and toys. Batteries store energy in the form of chemical energy. How batteries work. Batteries are made of special metals and chemicals that store and move electricity. When you need energy, you turn on the device. A chemical reaction changes the stored energy into electricity. Different types of batteries. All batteries have metals and chemicals. They make a force that moves electrons. Batteries use different kinds of chemicals and metals depending on how much power they make. There's a different battery for every need. Alkaline, AAA, AA, C, and D batteries are used in toys, simple games, and small flashlights. Lead-acid batteries are used in automobiles. Lithium batteries work on a camera, and lithium-ion batteries are used in laptop computers, cell phones, and digital cameras. Chapter 5. Sound Gets Around. Your favorite band is in a studio and ready to record a new song. Each band member has a microphone. The band plays. The instruments send sound waves to the microphones. The microphones change the sound waves into electrical energy, which is changed to a digital code and stored in a computer. A recording engineer uses a soundboard in a recording studio. When you listen to music, the digital code is changed into an electric signal. The signal goes to your speakers or headphones, which have thin, flexible sheets inside. Electrical energy causes the sheets to move back and forth. These vibrations are sound waves that you hear as the music. Supersound. Dolphins use sound to learn about their world. A dolphin makes clicking noises that travel through the water as sound waves. When the sound waves hit objects, they bounce back to the dolphin. These are called echoes. Echoes tell dolphins if something is hard or soft, near or far, and what shape it is. Using energy. Ride a bike, play a game, switch on a light, use a computer. These everyday actions use and change energy. People are finding exciting new ways to transform energy. Amazing things are possible when energy changes. This kind of stove allows people to cook food by changing light energy into heat.